Hi, I'm Mike Stanzik and this is Digital Electronics Classroom. Thanks for being here today. In this video we're going to look at the Demultiplexer, or the Demux. And it's just going to be an introductory video to show what it does and how we build it. Alright, let's get started. Demultiplexer, or Demux, is a data distributor. What that means is that it takes one input and it routes it to one of 2 to the n outputs selected by n selectors. Alright, so again we have this trapezoidal shape, but it's the opposite direction of the mux, and it has one input, we'll call it I, and then we have selectors, and so let's say we had S1 and S0, and then we have outputs so Y0, Y1, Y1, Y2, and Y3, that's a 1. Okay, and so essentially what this is doing is based on the output, or the selector. So if the selector says, hey, we're selecting 1, then this is going to route the channel I into output 1. And that's what it does. So it's just a routing. It selects one output channel to route the input into. Okay, and so, you know, this might be a situation where, you know, you have your iPhone playing Spotify, and you know, you have it connected to this speaker in your iPhone, and you have it connected to the Bluetooth, or sorry, to the speaker that you have, like external. And so the routing might be to your iPhone speaker, or the routing might be to the external speaker. Now, I'm not saying that that's the mechanism that's used, but just an example where you have one device connected up to multiple outputs, and you're saying you want to select one of those outputs, and you can use that Demux to do that. Okay, and so the Demux is a selector, and it selects an output channel. That's why we call it a distributor. We distribute to the output. And so anytime that we have a selection, it's useful to use an AND gate, because an AND gate is very selective. So in this case, we can use an AND gate, or a series of AND gates, to go ahead and make this selection. And so we'll have S1 and S0, and then we'll have our channel I, our input I. And so I is going to go to every AND gate, because we want to be able to send I on to the outputs. All right, and then these would be our outputs. So this would be Y0, this would be Y1, this would be Y2, Y3. All right, so we can send I to each of these outputs. We got to select which one gets it, though. And so that's when our selectors come into play. So when it's 0, 0 on the selector, we should send the output to Y0. So that means I got to invert those to 1s. And so I'm going to want S1 to be a 1, and I want S0 to be a 1, so I take the inverted of each of those. Okay, ooh, close, almost connected to lines. And then for Y1, we want the input to be 0, 1, but the AND gate needs to get 1, 1, so we need to invert S1. So So we invert S1, but we take S0 by itself. Like that. And then for 2, we need 1 and 0. So 1 is good for S1, but we need to invert S0. So we have S1. And then we have inverted S0. And then for Y3, we need S1 and S0. They're both 1s, so we just connect those to S1 and connect it to S0, like so. And there it is. This is a demux. We'd say this is a 1 to 4 demux. So, yeah, so that's it. I was going to simulate this for you guys, and let's see if we can do that quickly, because I actually forgot to set that up, so might not be able to. Okay, this looks like it's working a previous circuit here. So let me go ahead and see if we can open up a new one. Discard those changes. Oh, I think we're in luck. Okay, great. So let's go ahead and make this demux. And so I'm going to put in my AND gates, and these are going to be 3 input AND gates. 3 input AND gates, so go ahead and have 1, duplicate it, 2, duplicate it, 3, duplicate it, 4. Okay, and then these are each of our outputs. And for our outputs, we want to I'll go ahead and put LEDs. And so we'll go ahead and I'm going to do this in a little bit different way. I'm going to put them down here. 2, 3, and 4. And let me do something. Maybe we can clean this up a little bit. There we go. Okay, and then we're also going to use a different, well, we're just going to put one resistor in here. You know, normally I would have a resistor for each of these, but in this case I'm just going to put one resistance. I guess we're selecting each of the path individually, so I can just put the 220 in here. Okay, great. And then we need ground. Okay, and so we'll go to 1, 2, 3, and 4. And let's change this to white, because I like that one. I think it's more visible as white. Probably should have done that before I copied them over, but that's okay. It's not taking that long. All right, great. And now we have our input. Our input this time is just going to be a digital constant. So there it is. So that'll be able to be a 1 or a 0. And then we'll go ahead and connect all the way down. Then we need our selector switches. They're also going to be digital constants. And we'll duplicate. Okay. And then we need inversions for those. All right. There we go. Hopefully this will work out. Okay, so for 0, 0, we need both of them inverted. And so we'll go S1 inverted and S0 inverted. For 0, 1, we just need S1 inverted. So we can take this to S1, and then we need a non-inverted. Okay, we can do that. Non-inverted S0. And then for 1, 0, we need an inverted S0, so that would be right here. We need a non-inverted S1. Looks good. And then we need a non-inverted S1 and a non-inverted S0 for that final channel. Okay, great. So let's go ahead and make our data channel a 1, and so everything else should be a 0. And so let's select, we'll go ahead and start this up. So we'll select 0, 0, and so that's our 0th channel. So that 1 is, when it's a 1, it turns white, remember, so that's on. And so then the channel 0 gets turned on, and then if I select 0, 1, channel 1 turns on, and then 1, 0, channel 2 turns on, and then 1, 1, channel 3 turns on. And so this is indeed routing the input to the proper output, and so it's a demux. Okay, great, that's it for today. I hope you enjoyed. I hope that made sense and has value for you. I'm Mike Stanzik, and this is Digital Electronics Classroom. Please like and subscribe. Have a wonderful day.